Hi everyone. I was reminded today that I had never redone the video for Monday's Zoom class. That was the one that I had some trouble getting to upload. So I'm just going to do a quick recap of that and put it up today so you can see what we did on Monday. Some of that will help you with the homework assignment that I put up. So on Monday we talked about a few things. We talked about length, area, and volume. We'll get to those in a minute. And then we also talked about measurement. So, measuring with a ruler is a little more abstract, but what students may do first is they might learn to measure using objects. So let's say we want to measure this clothespin. You might give your students a box of paper clips all the same size, and they might be finding out how many paper clips long that clothespin is, right? Obviously, we don't use paper clips as a measurement every day, but it's just the idea that you can measure by using some kind of unit. You could also then say, okay, if the clothespin is 3 paper clips long, then would the marker be more than 3 or less than 3 paper clips? That idea of comparison. Then when you do move on to measuring using rulers, again, it's a little bit abstract, almost like a number line kind of idea, but the students have to realize you want to start at 0. You don't want to put your object starting at 1. If you just put your object anywhere, then this is not 5 inches, right? You have to start back here at 0. Notice that the 0 line is generally in a tiny bit from the edge. So if your edge gets a little bit worn off or something, you can still get that 0 line. So you want to start at the 0, not at the very edge of the ruler. And when we do measure, you can see here where the end of the clothespin is. And during class, I put this little extra mark there for that. So if we look at where that is, a common mistake would be that some students would say, okay, well, it's 1, 2, 3, 4 lines in from 3 inches. So that means that my clothespin must be 3.4 inches long. Okay, which is tempting. However, not quite correct, because if we remember our decimals, this means tenths. So this is 3 4/10 inches. You can think of it also like this. This, though, remember, means that I have 4 parts, and each part is 1/10 of the whole. Well, if I look at my ruler, there are not 10 parts between 3 and 4. If we count those lines, there are actually 16. So each of those lines is 1/16 of an inch. So it is not 3.4 inches, or 3 4/10. It is 3 4/16 inches. Or you could change that then to a decimal. Okay, but the temptation often is for people to just count over how many spots and call it point that, regardless of how many places there are. We can only do that when it's tenths. Now, if you're working with centimeters and millimeters, then you can, because there are 10 millimeters in a centimeter. So the decimal or the metric system is based on powers of 10, so that makes it a little bit easier. Okay, so then we got into length, area, and volume. So just real quickly, length we could represent by a piece of string. I don't know how easy it is to see that, but a piece of string, right? It just goes from one point to the next. It doesn't have any depth or height. So length, again, just think about from one point to the next. And we use units such as centimeters, feet, miles, inches. Okay, those are not all of them. Those are just some of the units we use. Area, we could represent by my little piece of paper here. Probably should use different colors so it's easier to see. But this paper, it covers space going this way and going this way, but this is supposed to represent that it really has no depth. Okay, so area is just flat. It's 2-dimensional. So length is 1-dimensional. Area is going to be 2-dimensional. So if I have a shape, a flat shape, I could then say, okay, how many of these papers does it take to cover that shape? That's area. And because our area has a unit or a measurement this way and this way, we use square units, square centimeters, square feet, square inches. You can write it with the exponent, or you can write it out like that, square feet. Okay. We see area in everyday life or hear those units. If you look at a house listing, it might say it's 2,000 square feet. That's the area of the living space, the floor of the living space. You might see it in an ad for a rug or tile or something. It might be $3.99 per square foot. Okay. And then finally, volume can be represented by my little block here. Okay. So not only now are we measuring in one direction, left and right, also up and down, also depth, also back. So we're looking at 3 dimensions now. So volume, instead of being a flat surface like that, we're looking at something 3-dimensional. Okay, like a box. And so if I were trying to figure out the volume, the inside space of the box, I wouldn't just have my little flat piece here. I would want to put little blocks in there, right? I would want to say how many of these blocks fill up this box. Not only the bottom of it, but then also going up to fill up all that space. Here we have measurements in 3 directions. Here, going back, so we might call this width, depth, and height, or width, length, and height, depending on how we just call those. So this is cubic feet now, okay? So cubic centimeters, cubic feet, cubic inches. Again, you can use your exponents, or you can write it out, the word cubic. Okay, so in general, most area and volume units are either squared or cubed. There are a couple exceptions. Like if you hear about land that it's in acres, so many acres of land, an acre already is an area unit. We don't have square acres. Acres is squared. Same with volume, like gallons, it's just a volume unit. We see cubic feet in everyday life. If you are ever shopping for a freezer or a refrigerator, you'll see that the volume is given in cubic feet. Sometimes maybe with a pool, they might tell you the volume of that if you buy a pool. So we talked about this. And then the next thing, and this goes along with the first question on your homework for this week. So the next thing we did was to say, okay, you have a rectangular garden. You're going to make a rectangular garden, I should say. And we want the area of this garden to be 24 square feet, okay? And we want the sides of this rectangular garden to only be whole numbers. So one side might be 3 feet, but not 3.7 feet, okay, for this. And we want to know what is the perimeter of this garden. And just a reminder, perimeter is the length all the way around the sides, the measurement of all the way around the sides. So if I have a rectangular garden, the perimeter is if I were a little bug and I walk this way, and this way, and this way, and this way. So add up all the 4 sides, that's going to be your perimeter. Okay. So what I'd like you to do is to stop the video for a minute, and try this on your own. So let me just explain again what you're trying to do. You're saying, okay, I have a garden, it's a rectangle, it's 24 square feet. So think about what I would have to know to find the perimeter, and what an example could be of what the perimeter is. Okay, so little hint, you're going to have to know the sides, right? So think about what sides would give you 24 square feet, and then what would the perimeter be. Okay, so you can pause the video for a minute, try it on your own, and then come back. Okay, so hopefully you took some time to try that out, to see what you could come up with. So when we did this in class, I put people in groups, and one of the first things that the groups came up with was a rectangle that looked like this. Okay, 6 feet times 4 feet. So 6 feet times 4 feet does equal 24 square feet. And if you need another visual of this, think about if I were to mark this off with a tape measure. Okay, so I went 4 feet, 1, 2, 3, 4, and here I'm splitting it into 6 feet. Okay, and if I were to, mark those measurements all the way across my garden plot, each of these is 1 foot by 1 foot, right? It's a square foot. So if we counted, there are 24 square feet there. All right. So, if I have this, my perimeter is going to be 6 plus 4 plus, remember, if I'm walking all the way around the shape, I have another 6 and another 4. Okay. So this perimeter is going to be 20 feet. Notice that my unit here is just feet, not feet squared. I'm just looking at length. I could have taken that piece of string and gone all the way around this. Okay. Is this the only answer? No. Maybe you came up with a different one, right? Another one we came up with in class was 8 feet by 3 feet. It's a little bit narrower, a little bit wider, a little bit shorter, a little bit wider. How do we know that 8 and 3 works? Well, because 8 times 3 is also 24. So you could also make a garden that's 8 feet by 3 feet. That still has an area of 24 square feet. What's the perimeter now? Well, now, again, think about having all 4 sides. 3 plus 8 plus another 3 plus 8. 3 plus 8 is 11. So 11 plus 11 is going to be 22. So we have 2 different gardens that have different perimeters even though they have the same area. Okay. There are actually 2 more also. If you think about what pairs of factors make 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. So we already did these 2. We could have 2 different shaped gardens also, or different size. So 2 feet by 12 feet would also make 24 square feet. 2 and 12 is 14. I'd have another 14. Perimeter here is 28 feet. And the last one, you could have 1 by 24. You could have a really narrow little piece of land that you want to put your garden in. So it's really long and narrow. So it's 1 foot high and 24 feet wide. That still has an area of 24 square feet. The perimeter now, 24 plus 1 is 25. I'm going to have another 25. It's going to be 50 feet. So you can have the same area in different perimeters. In general, the closer you are to square, like the closer you are to having the sides the same, the smaller your perimeter. Okay? Because if you think about this, all of these squares in here, right? All those ones where I just kind of shaded, none of those sides of those squares contribute to the perimeter at all. But over here, it's 1 foot by 24. So these are all our individual, pretend there's 24 there, right? Every single square foot contributes to the perimeter here. So it's much larger. So this will help you with the first question that's on the homework. Now the first question on the homework is flipped a little bit. In that one, you have a certain amount for perimeter, and you're trying to think about some options of what your area or what your dimensions would be. Okay, but it's the same idea. The area and perimeter do not have to always match up and stay the same. Okay, so hopefully that helps if you missed on Monday. Again, as always, if you have any questions, let me know. The homework is up on Blackboard. It's due Sunday night, and I also uploaded an article there just about teaching about a lesson that was taught with area. Okay, so let me know if you have any questions or if I can help you at all, and have a great weekend and stay safe. Okay, guys, bye.